You know how sometimes two things can look exactly the same, but one is hiding a really dangerous secret? Well, today we're diving deep into the world of materials where looks are definitely deceiving, and finding that secret can be the difference between safety and total disaster. Okay, so let's imagine this. Two giant steel beams. They look identical, they feel identical, they probably even weigh the same. But here's the catch. One is perfect for a skyscraper, super strong. The other, it's brittle, and it's a disaster waiting to happen. So how on earth are you supposed to spot the imposter before it's too late? The short answer? You can't. Just by looking at them, there's absolutely no way to tell. The fatal flaw in beam B is completely invisible, buried deep inside its atomic structure. It's a classic case of mistaken identity, but in the world of engineering, it's a case you have to solve. So what's the big secret? Well, it all comes down to the recipe. See, most metals we use aren't just one thing, they're alloys. And you can think of an alloy like a really complex soup. You start with your main ingredient, maybe iron, then you add just the right amount of other stuff, a pinch of carbon, a dash of chromium to make it perfect. But if you mess up and add even a tiny bit too much carbon, the whole batch is ruined. The steel becomes dangerously brittle. So how do you check the recipe of a solid steel beam? It's not like you can take a little taste test. No, for a job like this, you need a specialist. You need a high-tech metal detective. And here it is. This machine is an optical emission spectrometer. I know it might not look like a detective from the movies, but trust me, this is the hero of our story. It can take a solid piece of metal, analyze it in seconds, and tell you its exact recipe, exposing any fakes on the spot. All right, so how does our detective get the information? Well, it starts with a very quick, very energetic interrogation. It basically makes the metal talk. The whole process kicks off with one incredibly powerful spark of electricity. Just a quick zap right on the surface of the metal. Now, what happens in that tiny fraction of a second is just mind-blowing. The whole test happens inside a little bubble of pure argon gas. That electric spark hits one tiny spot and heats it up to a temperature that's literally hotter than the surface of the sun. I mean, that's insane, right? All that energy creates this brilliant flash of light and leaves behind a little burn mark no bigger than 5 millimeters. And that flash of light? That's the confession. That's everything our detective needs. Now it just has to decode the message. And this is where the real magic happens. So, think of it like this. That big zap is like a super loud alarm clock for all the atoms inside the metal. It doesn't hurt them, it just wakes them up. And when they wake up, they start glowing, releasing all that extra energy as light. Here's how the machine decodes that light. First, it captures that brilliant flash. Then, inside the machine, that light gets split into a whole rainbow of colors, a spectrum. And finally, super sensitive sensors scan that entire rainbow, looking for specific clues. And this is the secret to the whole thing. Every single element, iron, carbon, chromium, you name it, has its own unique light signature. It's like a barcode or a fingerprint that's totally unique. No two elements have the same one. So by reading all those different fingerprints, the machine knows exactly what's in the recipe and how much of each ingredient there is. So once it's scanned all those fingerprints, the detective has its answer. The verdict is in, and this right here is why this technology is so incredibly important in the real world. Let's go back to our original mystery. The machine's report instantly shows that beam B, our brittle imposter, had dangerously high levels of carbon. The secret recipe is revealed, case closed, and a potential catastrophe is avoided, all in just a few seconds. And this isn't just about skyscrapers. This kind of rapid-fire analysis is absolutely critical everywhere. We're talking about making sure bridges are safe, that medical implants are made of the right stuff, that airplanes stay in the sky. It's even crucial for something as simple as sorting metals for recycling. The need for this kind of certainty is so huge that back in 2022, the global market for these metal detectives was worth around $400 million. That's the price people are willing to pay just to know, without a shadow of a doubt, what a material is really made of. But hang on a second. What if there's a flaw in the system? I mean, what happens if our detective gets its notes a little mixed up from the last case it worked on? Well, it's a real challenge, and it's called the memory effect. Tiny, microscopic particles from one test can sometimes get left behind inside the machine. So if you test a steel with a ton of chromium in it, a few of those little chromium bits might stick around and contaminate the next test, giving you a completely wrong answer. But of course, engineers came up with a really clever fix. Modern machines use a sophisticated argon flow system. Think of it like a tiny, powerful cleaning crew that comes in after every single test and just whoosh, blows out any leftover particles. This ensures every analysis starts with a clean slate so you get an accurate result every single time. So, when you step back, what we have here is a technology that lets us instantly read an invisible, secret recipe that determines the safety and strength of the entire world around us. It really makes you stop and wonder, doesn't it? If we can uncover secrets hidden at the atomic level, what other amazing mysteries are just waiting to be discovered in the materials that will build our future?